G'day guys, how's it going? So in this video, we're going to talk about something called a move in Rust. And essentially what a move is changing ownership from one variable to another, okay? So in most programming languages, you may see something like this. So I go let b is equal to a, where a is assigned to a string that says hello world. What you would expect is that b becomes a, right? So I'm going to put a little print line down here to indicate that b can now be a. And I'm going to just comment out for a second, a, right? We'll come back to that in a second. So I'm going to run this program. And as expected down here, you can see b actually spat out hello world, right? Now, it was able to do that because we assigned b to the value of a. But what actually happened here is more interesting. So if I uncomment out line 5 here, where I'm trying to print out the value of a, you're going to see IntelliSense is already complaining. But if I run it and we take a look at the error down the bottom here, it's actually going to tell us that there's an error, right? And the error it will say is borrow of moved value a, okay? So basically, we can't assign a value to another variable and then use that variable after the fact. Now, why is that? Well, let's just quickly discuss. So let's break down the little program that we just looked at, right? So if we look at the first line where we set let a to string from hello world, what's happened is, once again, we've assigned an address on the stack for variable a, and that's pointing to some string in our heap memory, right? And then what happens is we've said to it, okay, now I want b to be a, right? That's the next line. Now, in some programming languages, what will happen is a secondary variable or pointer would be added and would point to the same location in the heap memory. But in Rust, remember we have that concept of ownership, right? And the rule is that only one variable can own a piece of memory at a given time. So because of that, what ends up happening is we perform a move, right? So what happens is a now no longer points to the heap memory, it points to nothing. Therefore, it's got no value. There's no point even trying to access it after you've moved it, right? And now b becomes the thing that we have to use in order to access that piece of memory again. This is what we call a move, all right, in Rust. So that is what has happened so far in that little program. Now, let's look at some more examples of moves in Rust so you've got a better understanding on how it works. So I'm back in the code, and now it should make sense to you why this print line here does not work, right? Because a no longer is pointing to anything, so therefore we shouldn't be able to access it. So let's just comment out that print line for a second. Now, that's a simple example of a move where we just look like we're assigning one variable to another, but there are other situations where a move can take place. And one of them is when we're passing an argument into a function, and that function is expecting a reference. So, for example, what I mean is if I do something like print string, right, and I expect a string there, and then I decide I want to print line out, print string value is, say, s, like so. If I call this function, say just below this line here, and I'll pass in b, which is valid, right? Considering it's now the new owner of a. It's now the new owner because it took it from a. What's going to happen is we're going to get another issue, right? And that is we're going to have the exact same problem, right? It's going to tell us borrow move value b. And that's because when we call a function passing in a reference type in this manner, and we'll see a better example of how to deal with this later. But if we pass it in this manner, what we're telling Rust is that we want to issue a move between the b variable in the main function to the bounded s in the print string function. So s in this situation now is the owner of hello world, right? So it's now pointing to hello world in memory. And the important distinction here is that when this function ends, S is cleaned up or removed, therefore hello world is cleaned up in memory. So not only do we no longer have any value for B, this hello world string is also gone because we've moved the ownership into the lifetime of this function now. Cool? So what that means is in order to fix a situation like this, we have to reference it. Now, I'm not going to show you that in this video. I just want to quickly show you that when you do this by default, you're going to get that move behavior when you call a function. Now, I could go the other way too. So if we do something like fn get a string and we return a string, let returned string equals string. Whoops. Just forgot the string up here. Just realized. String dot dot from. It's not dot dot. Colon from returned string. All right. If I now just go return string, whoops, like so, what this is going to do is it's going to instantiate the return string on the heap. It's going to point it to return string on the stack frame for get a string. And then when we leave, I'm not supposed to have the semicolon there. When we leave, this value is going to be deallocated. But the thing is, because it's returning it, it's actually going to move the value or move the pointer that this was pointing to the thing that we're assigning it to over here, right? So what I mean is, if I now go, let C equals get a string, like so, right? And we print line out, we'll say C. What I might also do is I'll just comment out B for a second because we know it's going to create a compiler error. And we'll even comment out A and B up here. So basically, when we return the string from this function, we're actually swapping the ownership or moving the ownership from this variable in here to this variable out here. So technically, if it wasn't returning and destroying immediately here, and we tried to use this again, which we can't because we already returned it, it would have broken in here as well. So what I'm saying is, whether you're the caller or the callee, by either returning or passing as a parameter, the ownership will be moved to whatever it's going to be assigned to. So in the case of a return, it's whatever the variable is that's assigned to the call. And if it's in the parameter, then it's going to be, let me just comment this out. I'll comment out in a second. It'll be whatever the parameter is here, right? So that's it. Basically, it's trying to indicate that it works both ways. So if I now run this, you're going to see that it actually works successfully because, well, the ownership has been moved to C, so C is happy and C can be printed out, okay? Now, we can do something a little bit more funkier. We could write another function which takes in a string and then returns a string, right? So we could do something like fn update and return, string. And what I'll do is I'll make it a mutatable string so I can edit it in this function. And then I'll return the edited value, right? So then this function can do something like s.push. And I haven't shown you this yet, but we're just going to add, say, world here, right? And then I'm going to return s, okay? And then down in the code here, let me just comment out these 2 lines here. I'll just go let d equal, and we'll go string from hello. So we're instantiating a new string on the heap, and d on the stack will point to that string on the heap. And then I'm going to have let e equal to update and return string, right? Which I'm going to pass in d. right? Now, in this given situation, what we're doing is we're first initializing D, then D is handing or moving its ownership over to the parameter of update and return string. So this is now pointing to what D used to point to. It's then updating the value, right? Because we made it mutatable. And then it's returning the value down here back to the caller, which in this case is E, right? So now E has got access. S in this case is now no longer pointing to that heap, that piece of memory on the heap. And now E is, right? So it's still that idea of one thing owning things at a time. So what that means is down here, if I try to print mine, say D, like so, it's going to indicate that it's already been borrowed or moved, right? So borrow is the other term that we use as well when we've handed it over to someone else and we're not getting it back necessarily, right? And what I mean by not getting it back is D is not mutatable, therefore it can't be reassigned back. And I'll show you in a minute what I mean by that. So in this situation, we can't use D because D is set to nothing, but we can set it to E. Cool. And when we run this, now we'll get no errors and we get hello world, right? So this function is now taking the value that was D, it's appended world to it, returned it. The ownership is now with E, and E can print it out accordingly, right? Now, what we can also do is we could do something like this, right? We could say, let's not have E at all. I want to continue using D, right? And I can say, instead of saying let E, I can just go D equals. Now, it's going to throw an error right now because D is not mutatable. So we need to set that as mutatable. Oops, I got double D. Oh, my apologies. Sometimes the Italian sense get in the way. But now we set it to mutatable, it means it can be rewritten to. Therefore, the ownership can now be moved back to D because it's still really following the same convention. S is just moving, in this case, this function up here, it's just moving it back to whatever we're returning it to, which in this case is D. Now, it doesn't work if I don't make it mutable because D is read-only at that point. But if I make it mutable, then we can assign it, right? So in this situation, everything will still work the same. And there you go, okay? So that is how a move works in Rust. It still works on the idea that only one variable can own a piece of memory at a given time, which is still following that Rust policy. Cool. So that's move. In the next video, we're going to look at a copy in Rust and how that works for both a reference type like a string, as well as value types like integers and floats and things of that nature. Cool. So I'll see you all in the next video.